So hello and welcome to our February SERC Talk. It's our first talk of the year as well as the first of our three-part series on successfully applying agile methods for high criticality systems. So for those joining for the first time, again, I'm very apologetic that this is the initial experience. But I'm Mimi Marcus, your SERC Talk webinar coordinator, and hope you find the discussion beneficial. And we encourage your active participation. It looks like there will be multiple ways to join in via Bluetooth, which we'll be sending out shortly to all of our Mac users, but also anybody who's on the WebEx or only joined by phone. You can either use the chat module or the Q&A module on WebEx, or email me at mmarcus@stevens.edu, and we'll incorporate your questions at the end of our talk. So you are muted if you are in the WebEx, but again, please feel free to utilize any of those methods in communicating your questions or comments. So with that, Barry, I'll turn it over to you to introduce our speaker, our SERC Chief Scientist, as well as the SERC Talks Editor-in-Chief.
Okay, thanks, Mimi. I think we're very fortunate today to be able to hear from Jan Bosch, who is originally from the Netherlands, did most of his academic work in Sweden and was a professor for a while in some Swedish universities, and then later became vice president and head of the laboratory at Nokia Research Center, and was the vice president of engineering at Intuit, and he has been a pioneer in more advanced ways of using information technology and extending agile methods to use DevOps and various things like that. So I think we're very fortunate to have him talking about how things are going to work in the future. So Jan, I'm looking forward to your talk.
Thank you very much, Barry. I'm very excited to be here, and I want to thank you and Mimi for inviting me to come and give this talk. The talk is a little bit on the long side, and now that we're starting 15 minutes late, I'm going to talk relatively quickly through some of the early parts of the talk. But of course, if we have questions or anything, we can have some time at the end for questions. But once again, thank you very much, Barry and Mimi, for inviting me to do this talk. I'm really excited about this. As you can all see the title slide, what we're saying is what I want to focus on is speed, data, and ecosystems, because I think that those are the critical elements of being successful in a software-driven world. Now, if we go to the next slide, which you already saw there for a second, I often start with a little quiz and ask who this gentleman is, but in the interest of time, I'm going to hop over that. This is Douglas Engelbart, and maybe if you can click one more time. And he had this nice quote which says, "The digital revolution is far more significant than the invention of writing or even printing." And that is exactly what we currently see going on in the industry, that this whole notion of digitalization is really having enormous impact on the software-intensive systems industry. And if you click one more time, Mimi. If we go to the next slide, yeah. So often I ask people how many of the companies that were on the list in 2000 are still on the list in 2014. And if we click one more time, you can see that actually more than 50% of the companies, sorry, Mimi, one more click. More than 50% of the companies that were on the Fortune 500 list in 2000 are actually gone in 2014. So what we see is that there is an increasing pace of disruption in the industry. And if we go to the next slide, then you will see that what we see as an experience is, and Jim Collins, who wrote the book Built to Last, has been looking into this, is that companies on average, the time that companies last on the Fortune 500 has actually been decreasing from well over 50 years to 30 years to 15 years. And the latest research is actually showing that companies are now around 10 years on the Fortune 500 on average before they get disrupted and displaced by others. And the main cause, if you look at what happens at these companies, is that these companies fail to innovate and build new core capabilities. And at this point in the history of our industry, it is actually digitalization that is the new disruptor, and that's what I hope to spend a little bit of time. So if we go to the next slide, I wanted to get clear on the definition of digitalization. This is the definition by Gartner. Digitalization is the use of digital technologies to change a business model and provide new revenue and value-producing opportunities. It is the process of moving to a digital business. So that's what we mean with digitalization. If we go to the next slide, we can see how Boston Consulting Group is thinking about this. Basically, they're looking at a 12 blocks to create a digital transformation. Of course, it affects our products, so we add software to products, which then leads to digitally enhanced products. But it is also around data-driven services. It's about digital services. It's about software products. So pure software that is sold as a product. And then if you look at what happens to the core business functions in the business, well, we see that sales, channels, and marketing are affected, research and development is affected, but also manufacturing, supply chain management, HR, finance, and support are all affected. So it's actually something that touches all of the company, and many companies that I work with are still coming to terms with this. And it also requires a set of digital capabilities. It's, of course, around going agile, which I suppose that many of you are concerned with, but it's also about systems and technology platforms. It's about analytics and data integration, and about your digital partner ecosystem. And I hope to talk a little bit about that. If we could go to the next slide. And this is, so these are the 3 key takeaways that I'm hoping that you will get from this talk. The first is increasing speed trumps any other improvement that R&D can provide to the organization. And for the vast majority of industries, including these days, interestingly enough, companies that serve the military, for instance, the goal is continuous deployment of new functionality. So we see that in industry after industry, people are looking for ways to get to continuous deployment of new functionality through software, independent of the industry, and it's a quite interesting development that is happening, going on there. Second, effective use of data from customers as well as products in the field, as well as the ecosystems that we have around those systems and services in the field, are the next areas to exploit, to monetize. And then the final one is that I believe that we are seeing the first signs of the end of hierarchical organizations, and we're moving towards a new business operating mechanism that is focused on empowerment and autonomy. And that's what I was hoping to talk with you about. So if we go to the next slide. So this is the overview. So what I was hoping to do, and again, I will go through this relatively quickly, and if some of you would like to have a repeat of this talk or a longer conversation, I'm happy to make myself available after this talk. But I was hoping to give you a very brief introduction of who I am and where I come from, because I think it will give you an understanding of the background. Then I want to spend a few minutes on the trends in industry, and especially why is it that everything is moving to software, which is what I will do in the second part. Then I will talk about this new business operating system where I hope to spend most of my time, which focuses on these 4 elements that I had in the takeaways. So speed, data, ecosystems, and empowerment. And by that time, we'll have conclusions, and we'll try to wrap things up and leave some time for questions. So I will go through this. If we go to the next slide. So Barry already did a great introduction. I used to be a young and innocent professor of software engineering. Then I went to industry, spent time at Nokia and at Intuit, and then since 2011, I'm back in Sweden. It's the second time I live in Sweden, even though I'm doing this talk from Madrid in Spain. And I'm director of the Software Center. I also do some consulting on the side, and I'm involved in a number of startups. But my main job, if we could go to the next slide, is that I run something called Software Center. Software Center is a collaboration between 11 companies and 5 universities here in Europe. It started off as a Swedish initiative, then became a Nordic initiative, and now it's a European initiative. And as you can see, you may recognize some of these companies like Tetra Pak, which are very big on, for instance, milk and yogurt packaging. They built their own machines, and they're a very advanced mechatronics provider. Saab is the Swedish defense company. They make anything from jet fighters to radar systems to command and control systems. I think all of you know Siemens, a company of 350,000 people. Also Bosch, unfortunately not related to me despite the similarities in names, but Robert Bosch GmbH is in the software center Qualcomm. It's an SME from Gothenburg. Access Communications is part of Canon, is a web security camera provider. Volvo Trucks, which is the number 1 or number 2 truck company in the world, among others owning the Mack truck brand, I think known to you, many of you in the US. Volvo Cars, the coolest car company on the planet, of course, and then Boeing, through its daughter in Sweden called Jeppesen, Ericsson, and Grundfos are part of Software Center. And our goal is basically to improve the digitalization capability of the European software-intensive systems industry with an order of magnitude. And then don't ask me how we measure that, but we can come back to that. But basically the idea is to have a close collaboration between these companies and the universities to help these companies accelerate their pace of change towards a digitalized society and a digitalized company. If we go to the next slide. Very briefly about the topics that we're working on. We work on topics like continuous integration and continuous delivery and deployment. We look into architecture, anything from architecture technical debt management to systems architecture to interoperability and other questions, ecosystems APIs. We look into metrics and we look into customer data and ecosystems. We also have some collaborations on the building of autonomous systems. Some of you may be aware that in Sweden, the richest family in Sweden, Wallenberg, allocated around more than $200 million for a research program around autonomous systems. I'm involved in the software part of that program. There are a few other programs as well. And we also look into things like Internet of Things and systems of systems. And if we go to the next slide, we can see that I do not only work with metal bending companies, but we do some work with online companies as well. So that's a little bit of background. If we go to the next slide, what I'm hoping to do is to go to and give you a few thoughts on what I see happen in industry. I will do this very quickly, but what is important, I think, is to understand why everything is happening. So if you go to the next slide, you already saw it for a second there, the Gartner cycle, technology hype cycle from 2017. If you look at on the topics on this list, almost all topics are software driven. So I think that's an important takeaway. If you go to the next slide after that, what you'll see is one of my favorite futurists, Gerd Höfner. He basically identifies what is happening from a technology perspective. That's what you see on the left side on the screen. And then on the right side of the screen, you see the implications for that. And if you click 2 more times, Mimi, I think it's still in there, you will see that automation of everything and decentralization of everything are 2 big things that is happening. And that's what I see now with many of the companies that I work with. We don't want to better support humans in through technology. No, we want to completely replace humans. So if you look at self-driving cars, this is not supporting car drivers to do a better job driving a car. Now, what is actually happening is that we're trying to replace the driver altogether. And then around decentralization, although we all know about Bitcoin and blockchain, but in many industries we see examples of ways in which people are looking to get away from a single central trusted authority to more decentralized ways of doing things. If we go to the next slide. Then what you'll see there is Google, of course. Google has this nice quote where they want to have Google to be the third half of your brain. If we go to the next slide after that, one of the topics that comes up a lot and we've started to work a little bit on as well is this whole notion of deep learning, where I basically use multi-layered convoluted neural networks to train these networks to identify either vision or text or anything like that. And all those things, all those technologies are driven by software. On the next slide, you see the next thing, which is, again, an overview of, sorry, the slides are a bit of all the different aspects that are these days driven by software. Anything from logistics to infrastructure to even garbage collection, agriculture, forestry, of course, self-driving cars, of course, telecommunications, robots. In the military, we see a lot of work on drones. And then even the last slide before the click happened was around construction. Even construction, which is the slowest moving industry except for university education, is now finally being dragged into the 21st century. My wife is a professor of management and works quite a bit with construction management, and I'm always surprised to see that construction is the only industry that actually has had 0% productivity improvement between 1947 and today. It's unheard of. I mean, every other industry has had hundreds, if not thousands of % of productivity improvement, but construction is finally now catching on as well. If we go to the next slide, you will see the cycle of innovation, because why is everything moving to software? Everything is moving to software because we want to increase the speed of the cycle of innovation. So going from idea to building on that idea, delivering a product, measuring how the product is used, which then generates data, which I can then use to learn from, which then leads to new ideas. The whole notion is, how can I go through that cycle of innovation as fast enough? If you click on the next slide, and I'm going to use automotive as an example, then you will see that, for instance, in automotive industry, a car platform typically has a lifetime of around 10 to 15 years. And what does that mean? It means that I will go through my build, measure, learn loop once every decade and a half. If you click one more time, you will see a car. A car will typically take around 3 years, even though Volvo Cars wants to get it down to 20 months. But typically it takes 3 years to develop a car from beginning to end. So I go through my build, measure, learn loop once every 3 years. If I click one more time, I look at car software. Car software, we're now moving towards continuous deployment of software, even in the functional safety parts of a car. And I'm happy to talk about, in the end, how we're moving towards that. But car software can be updated every day or every week. Now imagine that it's every week that I get new software in the car. It means that through the use of software, I can have software-driven innovation cycles that are 2 orders of magnitude faster than anything I can do with atoms. So if you're wondering why the whole world is moving to software and why software is now so important, I believe that this is the core answer. It is because it allows us to have innovation speeds that are 100, 200, maybe even 500 times faster than anything I can do with atoms. And we can see this because if you look at click on the next slide, we can see that the amount of software that goes into products is basically increasing with an order of magnitude roughly every 5 to 10 years, depending on the industry that you're in. And if you click one more time, just as an example, and this is a relatively old slide from 2015, but the new Volvo XC90, of which Uber late last year bought 24,000 cars off, the XC90 has an order of magnitude more software in the car than any of the earlier car models by Volvo. So what we see is that there is an enormous amount of software being pumped into the cars. Now, 2 more trends that I want to talk about if we go to the next slide. And that is, one is data. There is enormous amounts of data generated in the world. It's very hard to find accurate numbers, but one estimate says that 50 terabytes of data is created every second. I think that's a gross underestimation. Maybe that's just the amount of data that gets stored every second. But if you look at a self-driving car, I think it's around 6 or 10 megabits per second that gets generated in a self-driving car. If you go to the next slide. And this is, I think, something that some of you may have seen, but this summarizes the amount of data that gets generated every minute on the internet. And if you look, for instance, for YouTube, in every minute, 72 hours of YouTube is uploaded on the internet. On email, 204 million email messages were sent in the last minute. And for those of you that know Tinder, I've been married for a long time, so I have never used the app. But the last minute, 500,000 swipes took place in Tinder. So this is just the amount of data that humans are now creating. And if you then look at predictions like done by Ericsson, that in a couple of years we will have 50 billion connected devices, the data generated by humans will just be a fraction of the amount of data that will be generated by others. So if you click on the next slide, so I think we will see fantastic amounts of data on that front. The final trend I want to talk about is need for speed, and I have 2 slides on this, so bear with me. But this is a slide that we already used when I was working for Intuit. I think many of you know Quicken, and then eBay, Facebook, and then Angry Birds is by Rovio. If you look at how long it took each of those products to get to 1 million users and to 50 million users, you can see a trend, and the trend is that it goes faster and faster from the point of new introduction of a product to reaching 1 million or 50 million users. And for instance, in the case of Angry Birds, it took around a month, and then there have been examples of mobile apps that reached well over 50 million users in just a matter of days. So we really see that the societal willingness to adopt new technologies is going faster and faster. If you click on the next slide, and this is a bit of a build, so bear with me here. So if you click, so if we assume that there's a company, so this is the financial reason for why speed is important, and the company has a product that has a revenue of around $1 billion a year, and most companies express their R&D budget as a percentage of revenue, and I put it to keep it easy at 10%, which gives me a $100 million R&D budget. If you click one more time, then we'll see that the product, the life cycle, the development cycle is 12 months. And if you then click one more time, I'm going to give you two alternatives. The first alternative is we're going to focus everything on becoming more efficient. And if we are successful, we're able to say we're 10% more efficient, we're able to develop the product and ship it after 12 months for only $90 million instead of $100 million. But the second alternative is, imagine that I would reduce my development cycle with 10%. Yeah, and assuming that I can put the product in market after 10.8 months rather than after 12 months, and assuming that I'm not cannibalizing any existing product sales, I'm adding $100 million of additional top-line revenue to the company. So there are very strong financial incentives to actually accelerate my product development. And if they click one more time, so there's actually, if you look at it from this perspective, there is nothing that you can do from an efficiency perspective that will outperform cycle time reduction. I think that this is a critical takeaway, because in many companies that I work with, I see that efficiency and R&D efficiency is viewed as a very important thing, and lots of energy is put into that. But to be very honest, nothing will beat focusing on speed. And the other thing that I noticed, that in many companies that focus on efficiency, they tend to put all kinds of board approvals and reviews and milestones and all kinds of other mechanisms in place with the express intent of making sure that nothing inefficient will ever happen in the company. But what we see in companies that focus on efficiency is that they get much more slow over time, because decision processes take much more time. Whereas when you focus on speed, what happens is that you focus on all the activities that are actually concerned with all the stuff that is not absolutely critical and not absolutely necessary to do on the critical path of a project. You either look to automate, do in a different way, a faster way, or perhaps take off the critical path in some way. And in that way, you actually become faster, but also not only faster, you also become more efficient. So if you focus on speed, you become more efficient, whereas when you focus on efficiency, you actually become slow. And in many companies, I see that that understanding does not really exist. So if you click on the next slide, we're going to go through this. So next slide, I want to talk a little bit about my reflection on that. I believe we're moving towards a fundamental new business operating mechanism that software-intensive systems companies will adopt, which will change everything in the company and not just R&D. And for this, I will use a very simple model. I often say that I'm not terribly smart, so I can only do simple models. So this is a very simple model. It basically says that every product, every platform, every product portfolio consists of 3 layers of functionality. At the bottom, there is a layer of commodity functionality, which is all the functionality that you need for your system to work, but no customer is going to pick you over a competitor because of this functionality. Then on top of that, there is a layer of differentiating functionality. This is the reason why you may pick company X over company Y, because company X can do something that company Y cannot. And then on top of that, you have an innovation and experimentation layer. That's where you try out new things. And what is often the case in innovation, there's a bit of a power function with the success of innovations. Typically, say 10% of innovations are successful, 9 fail, but out of those 10, the one that is successful then gets productized and pulled into the differentiation layer it sits there for a while, and then the competition catches up. Customers are less interested in that functionality, don't consider it that new and exciting anymore, and then it becomes commodity, so it flows down into the commodity layer. What is important about the 3-layer product model that I will use as a backdrop for the rest of this talk is that every one of these layers has a different function that I'm optimizing for. So in the commodity layer, what I want to do is I want to provide the commodity functionality, but I want to absolutely minimize total cost of ownership. I don't want to spend a dime more than I can to just provide a commodity functionality. In the differentiating functionality layer, there I want to invest. There I want to create variants and additional alternative execution paths and additional usability for issues for certain customer segments. There I'm willing to invest because what I invest there will drive differentiation, which will drive my revenue. And whereas for the innovation experimentation layer, what we'll see is that there is a lot of there I want to optimize for running as many different experiments as possible. If you look at web companies, they know that their success rate for A/B experiments is around constant, so it may be at 5% or at 10%. And they know that if they want to have more output from their development or their innovation engine, the simplest way to do that is just to increase the number of experiments I run, because if I run 200 experiments at a success rate of 10% instead of 100 experiments at a success rate of 10%, I will have twice as much output. So if we click on the next, go to the next slide, then what I see, and I think, Mimi, just keep clicking until all the boxes are filled, because this is a bit of a build and it takes a time to build. But these are the typical questions that I have noticed companies ask themselves in an end-to-end fashion. So the first is, how do I expand my innovation funnel? And for that, what we've seen is that the most effective way to get more innovation in is by partnering with your ecosystem. Then the next question that I have is, once I go from innovation to differentiation, once I identify a relevant innovation, how do I get it to market faster? And for that, we focus on speed. So we try to go and we really focus on speed, and this will come back on in some of the next slides. Then once I provide functionality that I think is differentiating, how do I know for sure that what I'm building is actually providing value for customers? Well, for that, I collect data to ensure that this is actually differentiating for customers and provides value for customers. Then once functionality starts to commoditize, how do I identify that functionality is actually commoditizing? And for that, I can, again, use data. And then finally, at the bottom, you'll see, how do I minimize total cost of ownership for my commodity functionality? And for that, you can, again, see the ecosystem. Then on the left side of the slide, and maybe if you click one more time, it will come up. Then the question is, how do I organize for this operating in this model? And for this, I believe that we're moving towards a new way of organizing, which is much more centered around empowerment and autonomy. And we're going to come back to that later on. So if you click, go to the next slide, then we'll see that I believe that we're moving towards a new business operating system. Sorry, yes, this one. That is focused around speed, data, ecosystems, and empowerment. We need speed because we want business agility. We want data because it allows us to instrument, measure everything that we care about. We want to partner with our ecosystem because we want to focus our own resources on differentiation and partner on innovation and on commodity with ecosystem partners. And we want to focus on empowerment because of the disadvantages that hierarchical organizations have that we're going to come back to later in the talk. So if we click, go to the next slide. And again, this is a build, Mimi, so just keep clicking until there is something under the most right bar. We have now worked with dozens of companies, and that was one too many. And we've now worked with dozens of companies, and we see that companies, for the speed dimension of what we've called the stairway to heaven, there is a very predictable pattern that almost every organization goes through. And if you look at your own organization, you can probably place yourself where you are right now and what are the improvement efforts that you're currently driving. So starting from traditional development, the first step is that organizations adopt agile practices, typically at first at the team level and then for the R&D organization as a whole. Even though many companies find this a difficult change, it's actually the simplest one that you have. The next step after that is that you move to continuous integration. That's when verification and the R&D teams together partner to get to continuous integration. Then we move to continuous deployment. And that means that I now need a release organization and customer support in place, because I'm pushing out new versions of my software basically at the same rate as the length of my agile sprints. And then finally, I can move to R&D as an innovation system, where I, even for embedded systems, can run A/B experiments out in the field. And if we go to the next slide, you'll see that what we see happen here is a pattern where we are systematically trying to reduce 6 feedback cycles. There is a development cycle. This is what is the iteration speed of the development cycle, a requirement cycle, a quality assurance cycle, a governance cycle, a deployment cycle, and a value creation cycle. And if we go to the next slide, then what I show in that next slide is that with every step that you go up, we go from 1 or 2 of those feedback cycles go from being long and slow to being sprint-based. And I don't want to talk through all of this, but what is important here is that if you have long feedback cycles, decision processes often tend to be opinion-based. And if you have short feedback cycles, you're able to move to data-driven decision-making. If we go to the next slide, I think I put in a few things of work that we've been doing. Yeah, so again, I don't have time to go into this, but we've done work on architecture technical debt that I'm happy to share with people if they're interested. If we go to the next slide, then what you'll see is some of the work that we've done around continuous integration. This is one of the techniques that we have used to visualize all the testing activities in a company. And again, I don't want to go into depth here because in the interest of time. So if we click one more time, go to the next slide. Sorry, I'm waiting for the slide to come up. So one of the things that we're working on is that we see that it is unfeasible for companies to have product teams. We really need to move to a single code base out of which we are automatically generating for every sprint basically the product-specific code. At that point, once I've generated the code for each of my products, I run it through a continuous integration environment, and if it passes all of the things that I basically am interested in, I can basically deploy the products software in the field. I'm working with several companies of this, and if you want to know more, let me know. But this is what I wanted to say, I think, about the speed dimension. So if we go to the next slide. And I'm sorry that I go through this so quickly, but we lost around 20 minutes in the beginning. Again, for the data dimension, and if you, yes, thank you. We see that there is a similar stairway where companies move from working with data in an ad hoc fashion, then they move to automated collection. So the automotive industry in the 90s already started to collect all data from every car whenever it went to service. The collection was then automated, but the analysis, reporting, and decision-making around that data was then still manual. Then you move to automation. That's when you typically have dashboards. The problem with dashboards is that they tend to be relatively static. Then you move to data innovation, where you have a constant flow of new interesting insights from the data that are basically being pushed towards the organization by people that are continuously looking for new and interesting correlations. And then the final stage is the evidence-based organization, where we look into where everything in the company is basically data-driven. And what is, I think, important to I don't have time to go into this, but if you go to IEEE software, I think we recently published a paper there, or it's about to come out, that basically describes this stairway in more detail. If we go to the next slide, you see a quote from Edward Deming, which says, what I see now in almost all companies that I work with that are really successful is that they follow this quote, which is, in God we trust, all others must bring data. If we go to the next slide, why am I so interested in data? There is this old study from Standish Group, which has received a bit of criticism from different corners, but I still think captures the majority of the thinking in this context, which is that of all the features and functions in a typical system, around 50% to 2/3 of all the features or functions in a typical system are never used, or they are so rarely used that the R&D investment in them was not justified. And if you click on if you go to the next slide, you'll see some of our research that we did in Gothenburg with a company where we see basically the same pattern. We see a few functions here called services that are used very, very frequently, some functions or services that are used periodically or occasionally, and then a very large number of functions that are never used or hardly ever used. And I know what's going to come up in the questions. There are functions that you need in your system because of regulatory reasons or because of safety reasons, and you actually hope that they're never used. Sure, we've done a lot of work on that as well. These are the features that you want to see in use on a frequent basis in your system. And what we see is that for the typical company, about 50% of all your R&D effort into new features is actually wasted, and you don't know which half it is because you don't have effective mechanisms to working with this. And if we go to the next slide, again, I don't want to spend time on the HyPEX model, which is what we're presenting here, but the idea here is that rather than building a feature top to bottom, including the kitchen sink, what you do is you build the first 10–15% of the feature, you measure how it performs in the field, and you compare what you're getting back in terms of behavior from the field to the expected behavior that you've specified before you start development, and then you get into an iterative cycle where you ensure that you are developing functionality that is actually adding value. During the time that I was at Intuit, for instance, if you look at QuickBooks, we adopted this type of working, and we went from spending hundreds of person years in between proof points to determine if we were doing the right thing, to only spending a number of person weeks before we confirmed that we were actually building the right functionality. And I think that that's really important to get good at. If we go to the next slide, then I want to spend a minute on ecosystems, but actually the only thing I want to say about is that companies move from being extremely internally focused, so trying to do everything in-house, to over time becoming increasingly strategic in how they engage with their ecosystems. If we go to the next slide, you will see the stairway to heaven, the three-layer product model again, here with the reference in case you're interested and if you want to take a look at it. So just as a reminder, I have now asked well over 50 companies what in their self-assessment, how much of their resources are they spending on commodity functionality versus how much of their R&D resource or what percentage of their R&D resources go to differentiating, innovative, and experimental functionality. And the answer is, if you go to the next slide, is that around 80 to 90% of all R&D in a typical company goes to commodity functionality. That means that in any R&D organization, 8 or 9 of the 10, every 10 people are working on things that no customer cares about. Of course, they need to have it, but it is still commodity. It doesn't drive your differentiation. So we have this interesting situation, at least this is my current understanding in software engineering, where we, on the one hand, have that the situation where 8 or 9 out of every 10 people in R&D work on commodity, and on the other hand, the 1 or 2 people out of every 10 that work on adding new functionality to systems and get it wrong between 50 and 65% of the time. So I think that there's significant room for improvement to do better, to actually become more effective in our R&D. So if we go to the next slide. So we've worked, and again, this is a build, Mimi, so keep, I think 1, 2, 3, 4, I think it's 5 clicks that we have. What we basically say is that in our ecosystem, we have, in this three-layer product model, every company is part of an innovation ecosystem, part of a differentiating ecosystem, and part of a commoditizing ecosystem. They have different rules and different players. For instance, in commodity, it's perfectly right to collaborate with your competitors, because why wouldn't you? But if we go to the next slide, what I want to spend just a minute on is that our investing 80 or 90% of your R&D is not into commodity, is not a necessity. There are actually very good ways to decrease that. So if we look at the bottom part of this, this is a collection of all the strategies that are used by software center companies, the software center that I introduced in the beginning, of strategies that they use to decrease investment in commodities. So for instance, if we look at internal, Ericsson, whenever a platform or product is commoditizing, ships it off to a low-wage country in typically Asia, where Ericsson engineers, so there's an Ericsson side there, at a fraction of the cost of Swedish software engineers are maintaining that platform until it reaches end of life. If you look in the middle one, the collaborative one, Volvo Cars, BMW, and several other OEMs a few years ago created the Geneva initiative, where they decided to collaborate around the creation of an open source Linux-based platform for infotainment systems in cars. And their line of reasoning was, we all need a platform for our infotainment. It's probably better if we partner on that and together share the cost of creating that commodity platform, and then free up our own resources to focus on differentiating functionality in our respective infotainment systems. If we look at the external, one of the other companies in the software center, Axis Communications, is focusing on OSS integration, where they are basically looking at whenever some of their video processing functionality is, in their definition, commoditizing, what they will do is they will work with the Linux community to have the Linux community adopt that functionality. And the line of reasoning is that the Linux community gets access to pretty differentiating and advanced video processing functionality from their perspective, and Axis, once they have successfully transferred and integrated the functionality into the Linux kernel, will get that new functionality for free with zero maintenance cost in the future, because it will basically just come with the main Linux branch. If we go to the next slide. I think, yeah, so this is where we start to talk about why hierarchies are not the right way to organize anymore. But in the interest of time, Mimi, I propose that we click forward until we hit the conclusion slide, so we can spend a few minutes on that. There are several slides in here, and if you're interested, the slides will be available to you after this talk as well as this recording, and I'm also happy to talk to you about that. But one of the interesting things is that I believe that there are actually very exciting and novel ways of organizing coming forward that I think are much more suited than the traditional hierarchical organizations. So once we get to conclusion, yeah, here we are. So I have a few conclusions. The first is, in the future, all companies will be software companies. We see this even in the truck and automotive business. Even though those companies really pride themselves on being critically good at bending metal, they are now also seeing that it is actually in software that the real value lies for their customers. And we see this in telecommunications, we see this in automotive, we see this actually in defense. We see this increasingly in healthcare, interestingly enough, that it is becoming harder and harder to push the limit of physical, for instance, imaging machines, and have a good return on investment. And there is actually much more value to be gained by focusing on software, deep learning, and other technologies. So if we go to the next slide, I just wanted to repeat the things that we care about, that I said in the beginning that I was hoping to communicate. First, increasing speed trumps any other improvement that R&D can provide to the company, and the goal in all industries is continuous deployment of new functionality. If we go to the next slide, then this will be about data. Data. So data is becoming really important. This is not just about preventive maintenance and, you know, providing insight to my customers or to offer aggregated data solutions. No, this can also be used. All those use cases are great, but this can also be used to significantly increase the effectiveness of your R&D by knowing that what you're building is actually adding value to customers, and by not building what doesn't add value to customers, you can have a 50%, you can double the effectiveness of your R&D. If you click on the next slide, then it's about ecosystems. Being smart on how you partner with your ecosystems around ecosystems. Sorry, the slide is not updating, but we're going to the next one. How you working with your ecosystem, how you partner with your around innovation with your ecosystem partners, how you partner around commodity functionality with the ecosystem partners. Doing that smart can allow you to free up maybe 50% of the people that are, maybe even more of the people that are working on commodity functionality, and that will really allow you to invest many more people in differentiating functionality, which will be great for your competitive position in your marketplace. The next slide is the topic that we didn't talk about if we go there, which is about empowerment. But I believe, and again, this is perhaps a future talk, that we're moving towards a new business operating mechanism which is focused on empowerment and autonomy. Now on the next slide, when it comes up, yes. If you're interested in learning more, there is one book on speed, data, and ecosystems where I go into much more depth if you're interested in this. There's a short book that I published recently. It's only 65 pages around using data to build better products. And I'm working on a draft, and this will not be the final title, I think. The title will, I think, be different. But it's around how to work with the 3-layer product model to actually double your R&D effectiveness. So if you're interested in that, drop me an email or look on Amazon, because there you will find my author page in case you're interested. And if you click one more time, I think that's the final slide, if I'm not mistaken. No, this is upcoming events. So with that, here we go. So I wanted to thank you all for your attention. I'm sorry that we ran 1 minute late for my part. I'm happy to stay online for a few minutes to answer questions. If you're interested in a software center, go and take a look at software-center.se. If you're interested in me, there's my webpage as well as my email address. I also write a weekly blog post on LinkedIn, which I often push through Twitter as well, in case you're interested, and you can find the same information on my blog. So feel free to reach out. But thank you very much for your attention. I apologize for this speedy presentation, but we had some technical issues that caused us to start late.
Well, thank you, Jan, for a spectacular presentation, and again, with emphasis on speed. I'm sure there are several people that would have questions. Anybody want to ask away?
Sure, Barry, we have one via Blue Jeans, which is, for a life-critical, mission-critical system, what are the barriers and what do we have to do?
Yeah, that's a really good question. What I did together with Zenuity is that we have kicked off work on combining functional safety as specified, for instance, in standards such as ISO 26262 for automotive. Most auto industries have standards with different numbers, but those standards have typically very similar content. What we have, what we're now doing is we're looking on how can we combine the requirements of ISO 26262 with continuous deployment. And what that actually means is that you extend your agile development process with a continuous hazard analysis and safety case development in an iterative and cumulative fashion. Now, this is currently not industry practice. Actually, none of the certification institutes is supporting this. But I have noticed that we are working on this, and in several other countries, they are working on solutions to combine safety critical systems with forms of continuous deployment. Now, and then I know that within the community there are many people that are highly skeptical of this, but there's a very interesting difference, or not a conflict, but a different viewpoint between the security-oriented community and the safety-oriented community, because the security community is very adamant that the moment we find a security breach, we have to immediately and as quickly as possible actually patch it and fix it and deploy new software to address it, whereas the safety community tends to be much more willing to live with known safety issues. So I think that we will see a lot of transformation in that area, and we have some initial work on that, and we're planning the 3rd workshop in Gothenburg. And if anyone wants to come out to Gothenburg, it will probably in the spring, which is the best time to visit Gothenburg, then drop me an email and I'm happy to invite them to the workshop once I know the exact date for it.
Excellent. We also had a couple questions from Jack Ring. Jack, I'll unmute you so you can ask directly if you'd like. and you are unmuted. So, Jack, are you there? Otherwise, I can run through his first question, which was deploying new software versus deploying the same old stuff in new languages and architectures. How is it that the venerable math library of the 1950s has not become a monster in 60 years?
Ooh, sorry, can you repeat the second half of that question? So it's about building new software versus building existing software in new languages and for new platforms. Is that what I heard? But I didn't hear the second part of the question.
Yes. In regards to that, how is it that the venerable math library of the 1950s has not become a monster in 60 years?
Yes, so that is, I think, a really interesting question. We have done quite a bit of work on architecture technical debt management, and I think that many people that are online know about technical debt. We focus specifically on architectural technical debt, but what we see is that the companies that are mature, or not only companies, but also communities that are smart and mature about managing technical debt over time, are able to reduce the amount of resources that go to commodity and avoid the creation of monsters, as you called to, as that you just mentioned in your question. So I think it's a matter of the maturity of the community or the company that is actually doing this. Now, at the same time, there are companies that are failing miserably at this. For instance, a certain telecom company that shall remain unnamed had several blocks in its architecture, and some of these blocks were eroded so terribly that no one dared to touch them. So whenever there was a requirement, they had gotten the nickname stinkers actually within the company. Whenever anyone had to add some new functionality, what they would do is they would try to bolt it on by touching as little as possible of the existing software. And that pattern is, if you follow that pattern, that's when you get the monsters that Jack was referring to.
Excellent. He also had another question regarding how many bugs are propagated per second.
Poof. Yeah, so I'm actually not, I do not have any statistics on that, but it is an interesting question. However, so I cannot answer that question in terms of actual numbers. However, what I do want to stress is that in several companies that are more on the embedded systems mechatronics side, there tends to be a basic culture where people believe that testing something manually and slow leads to better quality than when you are testing something fast and automated. And that, I actually believe, is not true. If we look at companies that shift from manual testing to continuous integration, we see that the amount of times that test cases are run on the software and the amount of testing that a system undergoes is often orders of magnitude higher. And if you're then a little bit smart and you use things like risk-based testing, so you run test cases, automated test cases that frequently catch errors often, and you run test cases that only seldomly catch errors less often, so perhaps only weekly, you will actually see a significant improvement in quality. So I do want to, I'm not sure if that was what was behind Jack's question, but I do want to stress that continuous integration, when done properly, leads to a significantly higher quality. And I also want to stress that as you look in the speed dimension of the stairway to heaven, getting continuous integration in place is a precursor for being able to move to continuous deployment. And I'll leave it at that.
Excellent. I think there's also, and Jack, again, you're unmuted if you want to clarify on any of your questions. There was another one that he had that seems tied together, where it's how do you know what users want? And also, it seemed in follow-up to why does Volvo expect owners to appreciate a changed car every month or so?
Yeah, so for that, that's an interesting one. First, there seems to be a generational issue here, because that comment, and I have not met Jack, so I don't know, but I've noticed that young people expect continuous improvement of everything that they own and that contains software, whereas people that are slightly less young are more skeptical of it. And what is the other thing that I would recommend everyone to do is go to the Tesla website and Google for a video on that website, which I think is titled Better Over Time. And what they show in that video is several profiles of Tesla users. And I think you know that Tesla releases new software in its cars every 2 or 3 months. And then these users are basically telling their experiences with a car that gets better every couple of months. And it's interesting because, of course, I mean, this is done by Tesla, but they have very positive feedback on the fact that they have perhaps a car that is from 2012 that is still being updated and constantly gets new features and new functionality, and it actually gets better over time. And I think that that's where we want to get to. Why would we want a product that gets worse from the moment that I've bought it and it gets worse over time? No, I want products that have a certain functionality when I get them, and then I expect my products to get better over time. Why would we not want our products to get better?
Jack Ring here.
Yeah, hi Jack.
Hi there. Thank you. Excellent talk. Perhaps, but be aware that perhaps Tesla is experiencing people who are justifying their decision.
Yes.
All right, and whether or not the vehicle is creating better transportation at less risk to the environment is not even measured.
True. And I mean, I think that there are arguments that you can make for why Tesla is perhaps not the right example, but I gave this presentation on an iPhone. That iPhone is getting new software on a very regular basis, and except for the thing becoming a little slow over time, and that was a bit of a jab at Apple for slowing down my iPhone 6s Plus. What I actually like the fact that the thing is getting better, and if I look at my Apple computer, it's doing the same thing. The only thing, but what I do want to stress, like what we had this morning with WebEx updating and then suddenly not allowing all Apple computers to connect to WebEx anymore, that was a little bit less exciting, I must admit. So you really have to have your quality under control before you can actually do this continuous deployment. And then the final point that I wanted to make is I'm not sure how many of the people that are on the line work on for web companies or software as a service companies, but I think that if you go to booking.com, if you go to Bing, the Bing search engine, if you go to any of the big online properties, these companies are running thousands of A/B experiments continuously in their systems to constantly tweak and optimize the behavior of the systems. And partially this is, of course, to improve the revenue that they are generating from those systems, things like conversion, e-commerce websites. But partially it is also to give users a continuously better user experience so they actually keep coming back and using that service. And so I could imagine that there are situations where this doesn't work, but I do think that as a pattern we see that industry after industry is moving towards continuous deployment. Even Ericsson late last year announced that they now do continuous deployment of base stations. So every 2 weeks, base stations with selected customers get new software, and any customer that wants to get that is actually getting that. So I see it as a big industry trend, and I think that similar to the statement that you can do spaghetti programming in any programming language, we have to be a little careful on how we do it. But from a societal perspective, I can, at least from a descriptive perspective, I can see the trend very broadly in a lot of different industries that I work with.
Now, Jan, one more question that has to do with the experiences in your European companies. How long does it take somebody who has spent 20 years slowly going up the hierarchy to turn into somebody who is speed and horizontally organized? And what kind of incentive structures help that?
Yes, that's a really good question, Barry. And the point is, our experience is that depending on the size of the company, if you go to the speed dimension of the Stairway to Heaven, it takes around 18 months to go from one step to the next step. And that is what, for instance, well, I don't want to mention names of companies since I know that this is being recorded, but several of our companies are now started off with really seriously with Agile about 3-4 years ago, and they are now working very hard on getting good on continuous integration and starting to look into continuous deployments. And some of the other companies, and I already mentioned Ericsson, for instance, was already a little bit further ahead on Agile, then became very good at continuous integration, and is now working very hard on becoming very good at continuous deployment, and then moving towards the last step on that ladder, which is basically starting to use data to increase the effectiveness of their R&D. But my experience is that if you have sufficient management support, you have a number of people that are really enlightened and are driving the change, active change agents. It takes around 18, yes, this was the slide I was looking for. It takes around 18 months for larger companies to go from one step to the next step.
Okay, well, that's been really great, and I really appreciate your willing to spend extra time doing questions and answers, and I think you're really going to stimulate a lot of paradigm shifting that's going to go on over the next few years. So we really appreciate your talk.
And I really want to thank you, and the Stevens Institute for inviting me. And if there's anything that anyone wants to discuss with me further, I'm happy to either through email or in other ways share some more of my thoughts. So thank you all.
Thank you so much, Jan. I really appreciate it. And again, the talk for anybody who wasn't able to follow along is recorded and will be available on the SERC YouTube channel. And we also have our upcoming talks. Barry, I don't know if you want to mention them now that we have our next slated for April 4th and June 6th, continuing the Successfully Applying Agile Methods for High Criticality Systems series. And we will be sure to have some troubleshooting ahead of time for our next talk. Thank you again.
I should also mention that the talks beyond that are going to be focusing on how do you more effectively handle trade-offs among software qualities, and in particular emphasizing technical debt, which I think is becoming a critical driver and an opportunity for a lot of people that are creating complex systems. So that will be coming in the first half of 2019.
Excellent. And the dates are tentative right now, but we'll have the updates on the SERC Talks page as we set them more firmly. So thanks again to everyone for joining, especially Jan for bearing through some of our technical difficulties and giving an amazing presentation in a accelerated, speed-driven manner.
Okay, thank you very much. Okay, thanks everyone. Have a great day.